Hello, Assalamualaikum warahmatullahi wabarakatuh. Uh, my name is Ahmad Hazim bin Ahmad Nifiza. I'm a medical student, and today we will present on our findings about the assignment project. So the team consists of two people, me, myself, Ahmad Hazim, and Afi Alamin. And this research took about 2 weeks for us to fully complete. So first of all, before we start our research, before we start our explanation, we must first use the correct method of analysis to find our theoretical values. So for both of the circuits, we're using method of analysis, but because there are several branches that are connected to the same common nodes. So as for example, here there's around 4 branches, and here there's around 3. So there's a lot of branches that connect to the same node. So it makes us easier for us to conclude the one V1 node or V2 nodes. And then the voltage sources are connected to the ground, simplifying the node equations. So here we can assume that the bottom here is the ground, same goes with here. So here we have one big 4 nodes as a node, and here we have also 4. So it's also easier to use nodal analysis as compared to mesh analysis or conventional pictures file. So few equations required compared to mesh analysis. Yeah, there's like 1, 2, 3, 1, 2, 3, 4 here. It's quite difficult as compared to method of analysis. So how we construct our circuit in multisim? Firstly, place this DC current source and set the value as per the question. So here the current is 1, and we set it here as like a baseline for where our circuit begins. And then place the resistors we need we need to as per the question states.
Alright, now we are moving on to the step 3, where first we have to look at the menu and select the place basic. And then at the place basic, we have to choose the DC power supply and set up the value as per the question. Alright, now we are moving on to the step 4. To the step 4, we have to arrange all the components appropriately and then connect all the components. The way to connect it is, you're using your mouse on the computer and then select the end of each component and connect it to the other one. Yeah. And then on the step 5, because of you're using the nodal method, and then in the multisim, we have to put the ground into our circuit. Yeah, we have to choose one node that we want to use as the reference node, and then use it and place the ground there. Now we're moving on to the step 6. On the step 6, we have to place the voltage and current probe onto our circuit. Now, for the voltage probe, we have to place the probe at the left and right position of the resistor. For the calculation of the voltage, we have to calculate V, or the value of the probe on the left minus value on the right, and then we will get our voltage on that specific resistor. And then for the current probe, we have to put it on the position and direction that we want it to be as per the question. Now, for the step 7, stimulate the circuit, and then we will get our result.
So after we've completed our multisim circuit, we then calculate our theoretical value for the circuit. So I'll be explaining for the circuit 1. Circuit 1 is this one. Okay, in step 1, VA is a reference node next to a voltage source, hence VA is 12. So we assume here is VA, here is VB, VC, and VD. So VA is 12 as the voltage source is going into VA, and we assume VA is 12. Easy. Then step 2 is we will be constructing our first equation for VB. So here it states that VB minus 12 or VA over 4. VB minus 12 or VA minus over 4, which is this resistor. And then VB minus VC over 3. VB minus VC over 3. And then VB over 10, which is VB minus 0. Here we've assumed this is ground. VB minus 0 over 10, and then minus 4, as the current source is going in is 4 amperes. And then equation 2, C minus VB over 3, VC minus VB over 3, and so on. We'll be constructing our equations. After that, we've completed all of it. We can, from the equations, we can simplify it into a straight equation without any factors. It goes on for all of 1, 2, and 3. And we've made 3 new equations from this. From these 3 new equations, we can construct a matrix form and conclude that the answers are VB equals to 11.56, VC 2.69, and VD 4.78. Okay. And from there, we can make the answer that the I naught from our question, which is this part going to the right, is 0.1111 amps. Simplifying it into 0.11. Then VB, which is this part, which is also equals to the voltage across the R4 or the 5 ohm resistor, is 4.78. And then lastly, VB, which is the same volt across the 10 ohms, which is 11.56. And from the Markleson calculation, it simulated that the I here, the I naught here, which is this one, 1.11 milli. Milli is times 10 to the negative 3, which is 0.1111, so on. And then R5, which is PR4, 11.56. And then R4, which is PR2, 4.78, which is the same answer for our VD and VB and our I naught. So comparing the result for easier understanding, we compare that the simulated and theoretical values are exactly the same. And 0% plus 0% percentage error is calculated. Next to Afiq.
Alright, so now we are moving on to the second question, which is the circuit 2. As you can see here, we are using the nodal method, and for the first step, I draw the circuit and label and choose the reference and the unreferenced node, and then put our ground. And after that, I draw and determine the movement or the direction of the current. And so for the first equation, we do the KCL at the first node, which is the V1, and where I choose I use the sum of current in equals to sum of current out, and then we get the equation of the V1. And after that, I do the equation for the V2, still using the KCL at V2, and we use the same thing, which is the sum of current in equals to sum of the current out. And after that, we get the equation for the second equation. By having two of the equation, now we're doing the simultaneous equation, where I'm using the elimination method to get our result, which is the value of the V2 and V1. And after that, in order for me to get the I/O, which is the current, I use the Ohm's law and get the actual result for the I/O. And after that, for the calculation of the voltage at resistor 4 ohm and resistor 6 ohm, I still use the Ohm's law in order to get the result for both, which is negative 5.5 volt and negative 1.5 volt. Alright, so for the answer, for node V2, I got 4 volt. For the node V1, I got negative 1.5 volt. And for the I/O, I got negative 0.25 ampere. And for the V4 ohm, I got negative 5.5 volt. And for the resistor at 6 ohm, I got the negative 1.5 volt. Alright, now we are moving on. Let's see whether our result is the same as the one in multisim. As you can see here, after the simulation result, we can see that the result in the multisim is the same as what I calculated in our theoretical method, which is the nodal method. Now, as we can see the comparison of the result, we can see that the value for the simulated and the theoretical calculation is the same, which is we can show that the percentage error is 0%. Alright, now that is all from us. Thank you so much.